Greetings, Year 11 students. Today we're going to be talking about the sum and product of roots, so let's get into it. We're still talking about quadratics, of course. Now, let's just think back a bit to Year 9. When you were in Year 9, you learned how to factorise things like this question here. You'd say what numbers multiply to give 12 and add to give minus 7. Well, minus 3 and minus 4 are the numbers, and we could factorise. Then we went on further and we said, okay, we don't want to just factorise, now we want to solve. So we might have x squared minus 7x plus 12 equals 0. And then we would factorise, and we would say because it's equal to 0, we can get our two solutions of x equals plus 3 and plus 4. Done. Now those two answers have got special names. They're called solutions, or they're called roots, or they're called zeros, or they're called x-intercepts. Now, let's actually look at some extension work on this. We can actually write quadratic equations in this form, and I'll explain how and why in a moment. But if we do, if it's written in this form, alpha and beta are the two solutions that we got from solving our quadratic. Now, it sounds a bit strange. We've got some formulas here. I want to go and do the proof so we can actually link things. So let's have a look at this. All quadratics can be written like this in general form, can't they? But that could also be written like this. If I actually write a quadratic with an equals 0, let's put an equals 0 so we're solving it. I could divide everything by a, and I could get x squared plus b over a x plus c over a equals 0 over a. I could get that statement there. So that's a quadratic equation in general form, and that is the same quadratic equation, but I just divided everything by a. Now, if I have a quadratic equation that's written like this, that could be factorised into two brackets. Now, I haven't got a clue what numbers times together to give C on A and add to give B on A. So for the moment, I'm just going to say that the numbers are alpha and beta using Greek letters. And I'm going to say they're identically equal to each other. So now I can go x squared plus b over ax plus c over a is exactly identically the same as, let's expand these brackets out, so foiling it out, and I'll get x squared minus beta x minus alpha x plus alpha beta. Let's tidy this up a bit. And if I tidy it up, I get this. Now, it's a bit messy here. I'm focusing on this part here. X is common, so it's there. The minus is also common, it's there. So I'm just left with a beta and an alpha, which I'll write like that. If you wanted to expand the brackets, you could. Minus x times alpha is minus x alpha. Minus x times beta is minus x beta. Now if I'm equating both sides, let's equate the x squared terms of both sides. On the left side I've got 1, on the right side I've got 1. Well, I already knew 1 equals 1, so that doesn't help me much. Let's equate the x's. On the left side in front of x I've got b over a. On the right side in front of the x I've got minus bracket alpha plus beta. Well, I'm going to actually divide both sides by minus 1, or times both sides by minus 1, and I'll end up with alpha plus beta equals minus b over a. So that minus sign actually effectively ended up on the other side, and that's one of the formulas on our formula sheet. Let's equate the constant terms. On the left side I've got c over a, on the right side I've got alpha beta, and that is the second formula on your formula sheet. So what we're saying here is this: if you have any quadratic that's written in this form here, when you write it in that form there, if you were to be able to factorize it, put it into brackets, if you looked at the two solutions, I mean we're actually factorizing a quadratic, so let's put an equation. If we factorize it and we get our answers, our two answers, one answer we'll call alpha and the other answer we'll call beta. Our two answers will plus together to give minus this number over this number. And the two answers will times together to give c over a, which is this number over this number. Let's try some questions and see if we can make it make sense. Rightio. Consider 3x squared take 12x plus 2 where alpha and beta are the roots. Find alpha plus beta. Well, we've got a formula that says alpha plus beta equals, now what does alpha plus beta equal? It's going to equal b minus b over a. But what's b? Well, b is the number in front of x up here, so a is 3 and b is minus 12. So when I do that, I get minus 12 over the a number, which is 3. The two minuses cancel out. Alpha plus beta is 4. That means if I actually factorize that, use the quadratic formula on it, I'd get two answers. And those two answers, the two x-intercepts, will add together to give 4. Now, what will the two x-intercepts times to give? Well, we've got a different formula for what they times to give. We use c over a. C is 2, a is 3. They'll times together to give 2/3. Now this next one, I'm going to write down something that's just trivia here, but I want you to consider this. Alpha plus beta in brackets squared. If I expand those brackets out, smiley face it, I get alpha squared plus 2 alpha beta plus beta squared. What I'm going to do is take this term here and subtract it to both sides, and that'll leave me with alpha plus beta in brackets squared minus 2 alpha beta equals alpha squared plus beta squared. That is a formula that you should memorize. Because now when I'm doing this question, where I see alpha squared plus beta squared here, I'm going to use this formula. So let me clear all of that stuff away. Let's go back through it one at a time, unfortunately. And the formula that I told you was it's equal to alpha plus beta in brackets squared minus 2 alpha beta. Now, what is alpha plus beta? Well, I figured that out in part A. Alpha plus beta is 4. So that's going to become 4 squared minus 2 times, what's alpha beta? Well, alpha beta I figured out over here. Alpha beta is 2/3. So that's going to give me 16 minus 4 over 3, which will give me 14 2/3, or you can write it as a improper fraction if you like, it doesn't really matter. So that's the process there. Let's have a look at part D. Now, before I do part D, I want to be able to look at it and go, do you know, I'm adding fractions. I want a common denominator. So I'm going to times the first fraction top and bottom by beta, And the second fraction I'm going to times top and bottom by alpha, which will leave me with beta over alpha beta plus alpha over alpha beta, which is the same as alpha plus beta over alpha beta. But I know what alpha plus beta is. I did it in part A. I know what alpha beta is. I did it in part B. So that gives me 4 over 2/3. Put that in your calculator, you'll end up with 6. If you wanted to do it manually, you'd go, oh, that 3 goes up there. 4 times 3 is 12, so it's 12 over 2, which is 6. So that's playing around with roots of an equation. Let's try number 2. Find the value of k if one of the roots is 3. Okay, let's have a look at this. We've got A is k, B is 17, and C is minus k minus 1, because A is the number in front of x squared, B is the number in front of x, and C is anything that doesn't have x with it. Now, let's actually look at our formulas. I'm going to write down here sum of roots. Now, I know the sum of the roots formula is alpha plus beta equals minus b over a. But for this question, the roots are going to be called alpha, and I'm going to, instead of calling the other one beta, I'm going to call it the number 3, because the question says one root is 3. So I can call them alpha and 3. I could have also called them 3 and beta. Doesn't matter which way you do it. So let's come back to the question. Alpha is still alpha, but beta I know is 3. Minus b over a becomes minus 17 over k. And I'm going to stop there because that doesn't look particularly friendly. Over here, I'm going to write product of roots. And if I'm doing the product of the roots, it's alpha beta equals c over a. But I don't have a beta. I know beta is 3. So alpha times 3 is 3 alpha equals, what's c? Minus k take 1 over a, which is k. Wow, that's a mess as well, isn't it? So, in order to do this question, I've now got 2 messy statements. I'm going to look back over at this first one and minus 3 to both sides. That's equation 1. That's equation 2. And I'm going to sub equation 1 into equation 2. So everywhere in equation 2 where I see an alpha, it's going to be replaced with minus 17 over k take 3. So I'm now going to get 3 instead of 3 alpha. Remember, I'm copying it into this one here. Instead of 3 alpha, it's now 3 times that little mess equals minus k minus 1 over k. Let's expand the bracket out on the left side. 3 times minus 17 is minus 51, so it's minus 51 over k. 3 times minus 3 is minus 9. Now I'm going to multiply every term by k. And I'll end up with minus 51 minus 9k equals minus k minus 1. Well, that's actually good because now I can just solve this. I'm going to take this minus 9k and move it over to the other side, which will give adding 9k to both sides. 9k and the minus k give 8k. This minus 1, I'm going to plus 1 to both sides, which will give me minus 51 plus 1 is minus 50, which means k equals minus 50 over 8, or k equals minus 25 over 4, or minus 6 1/4, or minus 6.25. What a mess. But that's the answer to it. So some of these you can see get quite challenging. Let's have a look at example 3. Evaluate p if one root is double the other. So I'm actually going to make the roots, instead of alpha and beta, alpha and 2 alpha, because one of them has to be double the other. So let's look at the sum of the roots. Alpha plus beta equals minus b over a. Well, it becomes alpha plus 2 alpha equals, now what's a, b and c? A is 1 because the number in front of x squared is 1, b is 2 and c is negative 7p. So minus b on a will become minus 2 over 1, which means I end up with alpha equals minus 2/3. Now the question didn't say find alpha, the question said find p. So let's actually use the product formula. Now the two formulas, or the two roots, sorry, are alpha and 2 alpha, so it'll be alpha times 2 alpha equals minus 7p, because that's c over 1. 2 alpha squared equals minus 7p, but I know what alpha is. Alpha is minus 2 over 3 because I calculated that earlier. So minus 2 over 3 when you square it gives plus 4 over 9, times it by the 2 and you get 8 over 9. You can do that on your calculator. Divide both sides by minus 7 and you get p equals minus 8 over 63. And so that is the value of p if one root is double the other root. Time for you to try doing some fun questions. Enjoy.